In this video, we'll go over kinetic data analysis and a typical analysis example. Kinetic data is data measured across multiple time points. There are two main types of kinetic data, fast and slow. Fast kinetics is where all cycles are measured in one well before the next well is read. This is appropriate in cases where the reaction occurs very quickly. Slow kinetics assays read the entire plate once before returning for a second read. Regardless of whether the kinetics assay is fast or slow, the analysis process is the same. For this video, we'll go over how to analyze an enzyme kinetics assay. Please note there are many different types of kinetic assays, so your specific calculations may not exactly match those used in this example, but this will provide a good starting point. Typically, an enzyme kinetics assay is used to determine the rate of an enzymatic reaction. This can be accomplished by observing the appearance or disappearance of a substrate over time. The data analysis for enzyme kinetics will include a kinetic reduction followed by curve fitting. This kinetic reduction computes a single value for each kinetics plot. This could include calculating a slope, the area under the curve, or the total of measurement values. The curve fitting portion of the analysis plots the reduced value for each kinetic plot against unknown concentrations or doses. This can be used to then calculate the concentrations or doses of unknowns, or you can use the curve fit to report characteristics of the curve. I have open an example enzyme kinetics data analysis protocol. I'm working in Assays desktop, however, these same principles apply to any data analysis software. If you'd like to learn more about the data analysis products available from Assays, please see the link in the description. First, let's take a look at our measurement data. Here you can see the raw data on the left-hand side of the screen. The well identifier is at the far left, followed by a time or cycle value, and then the measured absorbance value. The right-hand side of the screen shows the thumb plot for each well position. Looking at the chart view, we can see in greater detail the measurements collected for each position. Now let's look at how the samples are arranged on our plate. This enzyme kinetics assay only includes standard samples in duplicate and a blank sample used for a background correction step. So for this assay, we're interested in parameters calculated from the curve as opposed to calculating concentrations for unknown samples. For this assay, the first step of the analysis is to perform a blank correction step, subtracting the values of the blank on a point-by-point basis. Next, we use the blank corrected values to calculate the total, or the sum of the data points for each plot. This total value is then used in a Michaelis-Menten Curve Fit, plotting the standard total values against the specified concentration values. This curve fit will return the Km and Vmax values, which are the values of greatest interest for this application. The Km value measures how easily the enzyme can be saturated by the substrate, while the Vmax reports the maximum rate at which the enzyme is catalyzed when saturated by the substrate. Now let's look at the results. On the Results tab, we can see the standard samples and the blank sample, their well locations, raw thumb plots, followed by the blank corrected thumb plots, and the total value, which is the sum of the blank corrected data points for each well. These total values are used as the y-axis values for our standard curve fit. On the Fit tab, we can see the curve chart fitting a Michaelis-Menten fit to the standard total points plotted against the specified concentration values. Below this, we can see additional information about the fit itself, the limits of quantification, curve fit equation, and the Vmax and Km values. Below this, we see the goodness measures and the curve data table, showing additional information about the standards, their defined concentrations, total values, backfit concentrations, %CV, and accuracy. This is one example of how kinetic data can be analyzed for an enzyme kinetics assay. However, there are many other different possibilities. For additional information on other options, please see the video links in the description. If you have any questions about how to analyze kinetic data or the data analysis platforms available, please email us at support@myassays.com or visit the link in the description.